Welcome back everyone. Today we'll be discussing another important topic, which is functions and graphs. So over the years, this topic has gained importance in the CAT examination. As a matter of fact, in 2024, there were almost 5 questions on this topic, and there are broadly 3 areas where they can ask questions on with regards to this one. This is first off f of x and f of transformed x, which is what it basically means is you change the input to get another function, and you try and find relationships between those. Try and find a relation between those functions, or it could be the vice versa. They'll give you this function, they'll give you this function, and then they'll give you a relationship between those two functions, and then they'll ask you what is the value of x or what is the value of a constant within x. So this is the basic model in which they can ask. So this is the first model. The second one is your modulus types. So modulus of x, and it will have an equation in terms of modulus of x. So when I mean modulus of x, it can be modulus of any function within x also. And for those, how do you solve is basically taking different values of modulus of x. So what does modulus of x have? Two values. It is either x or minus x. This is x when x is greater than or equal to 0, and this is minus x when x is less than 0. So using this basic simple property, you can solve any modulus question. It's an algebra, right? And then you have your third model of questions, which is your basic graphs and area under graphs, right? Specifically area under graphs. So all these problems have a singular objective of you drawing the functions, whatever the function lines it may be. So this could be function 1 of x, and this could be another function that they give, and this could be the third bounding function. So this could be the third bounding function. And they're asking the area that is formed within these curves. So if you observe, this would be the area that is bound by this curve, not this one, correct? Because, and then they'll obviously mention that within x and y axis, what is the area that is bound by these three curves. So, and then you'll have to find out what is the area of this particular curve, right? Yes. And in most cases, it will be through elimination method, meaning you would have to find out the area of this entire triangle and then eliminate the smaller triangles or any other methods that is involved, correct? So these are the three broad topics where questions are framed around. So without wasting any time, let us solve the first question on this. So this is the same model as we discussed before, just function and then replacing the input value for the function, and then there is a relationship between these two functions, and they're asking what is the value of, or what is the sum of all possible values of x for this particular value. So for you to do that, you would have to calculate what is f of x. So what is the function in terms of f of x? I'll give you guys some time, pause the video, solve it on your own, and then come back and see if the answer matches. Right, as soon as you see f of x and then f of 1 by x, your immediate thought should be, right, let me replace. So this is your original function, f of x plus 2 into f of 1 by x is equal to 3x. Then immediately you should be like, let me replace x with 1 by x. So what is going to happen? You will get f of 1 by x plus 2 times of f of 1 by x, which is again x, is equal to 3 by x, correct? Now you have two equations, two variables. What are the two variables? F of x. In fact, you have three variables, but f of x is inherently a function of x, therefore you will try to mention it as two variables. And then you have two equations, and let's try and solve for f of x, because we know the value of f of x, which is 3. So let us try and eliminate f of 1 by x. And how do you do that? You multiply by 2 on both the sides, and then you subtract these two equations. You get f of x minus 4 times of f of x is equal to 3x minus 6 by x. Now this will come out to minus 3 times of f of x is equal to 3x minus 6 by x. So if I remove minus 3 on both the sides, I'll be left with what? F of x is 2 by x minus x. So this is your final f of x function. So this is the final function. So clearly f of x is a function of x, and its value is equal to 3. It is equal to 3. Now if you observe, this is a quadratic equation, correct? So let us solve this quadratic equation. It is 2 by x minus x is equal to 3, and then upon solving, what do you get? X square plus 3x minus 2 is equal to 0, correct? And what are the roots of this equation? Before we do that, so that is our next instinct, right? So let us find what is the value of x. So x1 is how much, then the x2 is something, and let me then add these both. But then we obviously know that the sum of the roots x1 plus x2 is minus b by a, correct? So let us directly get the value here. It is minus 3 by 1. Therefore, the value is minus 3. Okay, before, these are all these small steps, tiny adjustments that you do while solving these problems is what saves you time. This would have taken an additional 1 minute, but now you know the answer directly, correct? So this is how you solve functions related questions with different inputs. So let us move on to the area related question basis the graphs. So pause the problem, try to do it and then come back here. So first let us draw the, before we okay, this is a combination of both areas and modulus. So let us try and first simplify this. So the lines, right? So x minus y, so it can have both positive values and then negative values also. So let us do that. X minus y minus x minus of y is equal to 2. So very important thing to note, as soon as you write the function, it is important that you also write what are the conditions that this is true for. X is greater than or equal to y, and then okay, let me edit it in different color. Right, x is greater than or equal to y and x is greater than or equal to 5. For this is true, correct? So next equation would be x minus y plus x minus 5 is equal to 2. So what is the conditions there? X minus y, sorry, x is greater than or equal to y, then x is less than 5, not equal to, it is less than 5. Okay, and so the third equation would be what? Minus x plus y minus x plus 5 equal to 2. So here it is x is less than or equal to y and x is greater than or equal to 5. Next you have minus x plus y plus x minus y 5 is equal to 0. So this one is x is less than or equal to y comma x is less than 5. Sorry, it is just less than, not less than or equal to, because if it is equal to, then it should be greater than 0, right? So it will become positive, but we want it to be negative. Therefore it is x is less than y and x is less than 5 also. So now you have your 4 equations. All you have to do now is club these 2 equations along with these 4 to get your graph. So let us plot that graph. Obviously we cannot draw the graph to scale, so on a approximate basis let us do it. So what is the first line? Bounded by y-axis. So this is your y-axis. So anything that is right of y-axis is what is considered, is what this means. If it is bounded by y-axis, it means all the regions which is to the right of y-axis. Now we have the line x is equal to 5. So x equal to 5 line looks like this, correct? X is equal to 5. Next, what is this equation? This equation is y equal to 3 line. Y equal to 3 line. What is, let me check, this equation is done. Let me check this equation because x is getting cancelled here as well. So this equation is y equal to 7, correct? Intersection points we know 3 comma 5 and 5 comma 3 and 5 comma 7. So that is good. Next, so this equation also is done. So let us draw this equation. This equation is what? Finally simplified to 2x minus y equal to 7. And what is this equation? This equation is 2x minus y equal to 3. So let me do the third one first. 2x minus y. So let me find out the intercepts, and basis that I'll get your answer. So y is equal to minus 3 when x is 0. Equal to minus 3. X is 0. And what is the value of x? X is 3 by 2. 3 by 2. Correct? So this is something like this curve. So we don't know where it is intersecting. So let us check that. Where does this equation intersect y equal to 3 curve. Y equal to 3, you will get x value is also equal to 3. If you substitute and check, you will get that. And then where does it intersect? Y equal to 7. It intersects at 7, it becomes 10 and then becomes 5. So it intersects exactly here. So this is your final equation for 2x minus y is equal to 3. Now you want to see where this equation is. 2x minus y equal to 7. So instead of repeating the entire process again, you can just shift this curve by 4 units. So how much would that be? 7 by 2 would be here, and then here minus 7 would lie here. So this is how this equation would look like, correct? This would be 2x minus y is equal to 7. Now all we have to do is find the area within which is bounded by all these curves. So what is that area? It should be bounded by this curve, and these curves. So it is clearly this area, correct? Sorry. So this small triangle is also extremely important for us here, because that is how you're going to end up calculating the area of the required region. Now if you see how do we calculate the area of this particular red region, is how it's quite simple. We take this area of the entire trapezium and then subtract it from this triangle. That works, right? So what is the area of the trapezium? Half of height into height is how much? This is 0 and this is 3, so 3 into, so this is the height. And what is the sum of the parallel sides? So this length plus this length. So we know this length to be 5 minus 3 by 2 plus this length is how much? This point is the intersection of 2x minus y is equals to 3 and x is equal to 3. So this line we found it to be 3, right? So if it is 5 minus 3. This is the area of the trapezium minus area of the triangle, half into height. Height is 0 to, so this line intersects x equal to 5 line. So if I put x is equal to 5 here, you get y equal to 3. Oh, therefore this curve would be looking something like this. But anyways, so half of 5 and 3, so then this 3 again into curve would be looking something like this for reference and not this. So this would be the triangle that we are trying to remove here. We'll remove this triangle to find out this area. Of course, there is other methods to find out. This is obviously a parallelogram. And before we do that, since we are into this method, let's finish this. So this seems more intuitive because the triangle, sort of trapezium minus triangle, will give me the required area. So the height is known, 3, and base intersection point of x is equal to 0 and y, the y is equal to 0 and x is equal to 7 by 2. So it is 5 minus 7 by 2 should give you your final delta. So this is how you approach any area and modulus reported related problems, correct? So after that, let us try and solve another problem, which is a function wherein the inputs are another function. So this should be a simple problem for you guys, because we've already done different input functions, but the only caveat here is minimum values. So let us see how we can calculate minimum values. So there are couple of methods to do so. So let us see both, and then whichever is more intuitive and easier to calculate, basis that we can solve these problems. So let me calculate our objective function. Objective function, let me rename as h of x. So objective function is h of x is f of g of x minus 3x. Let me simplify this. So this is f of g of x is x plus 3 minus 3x. So what is f of x plus 3? it will be x plus 3 whole square minus 7 times of x plus 3 minus 3x. So let us simplify this equation. Sorry, what do we get on simplification? We got x square plus 9 plus 6x minus 7x minus 21 minus 3x. So the final equation would be x square minus x minus 3x minus 4x plus 9 minus 21 is minus 12, and this is your final objective function. Now they're asking minimum value of this function. Now there are two methods to solve this. One is through calculus, which is differentiation, or to try and apply algebraic techniques here. So first let us do it using calculus, and then we'll come to this algebra method. So calculus is straightforward. So h of x is known. All you have to do is put h dash of x is equal to 0. So what is h dash of x? H dash of x is the first derivative of this function, which is x square is 2x minus 4x is minus 4 is equal to 0. So x is equal to 2. This is where the minimum is at, or maximum. But obviously this is the minimum because the maximum value is infinity for this particular equation. So for at x equal to, what is h of x? H of 2 is 4 minus 4 into 2 minus 12, which gives you minus 16. This is the minimum value of this function. So this is using differentiation. Obviously many people might find this easy, but for those who don't, algebraic method is another method in where using which you can calculate the minimum value of this function. So in algebraic method, you have your h of x in terms of different variables. All you have to do is to bring it into a whole square plus some constant. So you have to bring it into a perfect square plus a constant, and then you can tell, okay, the minimum value of this function is, I can put the minimum value of individual terms, which is 0, and the constant. Therefore the minimum value would become constant. So that is the basic ideology behind this algebraic method. So let us try and do that. We have x square minus 4x minus 12. So here I'll try and make this item a perfect square. How do I do that? This looks like x minus 2 whole square, correct? Which is x square plus 4 minus 4x. So minus 4 is missing. This would bring it down to x minus 2 the whole square minus 16. So the minimum value of this function is minus 16. So this is also a method in which you can calculate the minimum value of any function. So bring it to a perfect square and then put that to 0, and then the remaining term is your minimum value. So let us solve another problem on similar logic. So let us simplify this equation to see how it looks like. 2x plus 1 by 2x is equal to 2 minus x minus 2 whole square. So our basic instinct would be, okay, let me expand this function and then try and multiply and then take 2 power x as some variable t and then try and solve it and see where this takes me. But before we do any of that, our first instinct should be, okay, if they have given a problem like this, which looks complex, and it is complex, and the probability of us solving for the value of x seems pretty unlikely. So all you have to do is, okay, let me see what the LHS holds and what the RHS holds with regards to range of this function, correct? So let us try and do that. Here, let me take this function itself. So what is the range of this function? Range of RHS. So we just saw that the minimum value of a perfect square is 0, correct? Therefore the minimum value of this function is 2, and the maximum value would be what? This is the maximum value. So the maximum value of this function is 2, and then the minimum value would be minus infinity, because if I put this function to infinity, it becomes minus infinity. So the minimum value is minus infinity and the maximum value is 2. Fine. Now let us see what the range of LHS is. If you guys observe, 2 power x plus 1 by 2 power x looks something like t plus 1 by t. Okay, let us assume this is how it looks like. They're asking what is the range of this function. If you guys aren't familiar with how to calculate the range of this, there was an inequality in your previous classes, which you guys might remember, which is am greater than or equal to gm greater than or equal to hm. So this inequality gives us an idea about what the range of these kind of functions are. So let me apply this same rule here. We'll see what we'll get. So what is the am? What is the arithmetic mean of this function? It is t plus 1 by t by 2, correct? It is greater than or equal to, what is the gm? Square root of a and b, so it is t into 1 by t, gets cancelled. So it gives you what? T plus 1 by t is greater than or equal to 2. Therefore the range is minimum value is 2 and the maximum value is infinity. Of course you can do this by simplification as well. Simplification, I mean substitution as well, wherein you put this value to infinity, okay, the maximum value is infinity. Put this value of 0, again you are getting it as infinity. Therefore the value somewhere lies in between those 0 and infinity. Therefore it is 2. If you observe, these both meet at only one point. So this is the only point where RHS and LHS are equal. Therefore LHS equal to RHS equal to 2. Okay, fine. Now let us see what is the value of x for both LHS and RHS for which this is equal to 2. Okay, what is the value for which this is equal to 2? It is clearly t equal to 1. So when I mean t, it means 2 power x is equal to 1, which means x is 0. X is 0 for LHS. Now let us see for RHS what is the value of x. So 2 minus x minus 2 whole square is equal to 2, which means this should be 0, which means x is equal to 2. So if you observe, x is not equal on both LHS and RHS. Therefore there is no single value of x wherein LHS is equal to RHS is equal to 2. So the number of real solutions for this equation is 0. This is how you approach these kind of problems. So before you guys go on expanding and then trying and putting values for x and 2 power x and solving, try and think from a outside perspective, like what is the range of this function, what is the range of that function, do they intersect or not. So that is how you approach these kind of problems. And trying remembering certain inequalities also helps, right? So let's solve the last question for today and then we can close. So as I already mentioned, as soon as you see a quadratic equation in terms of modulus, you simply write down all the values for different values of the modulus. Plus a minus 2 at the inequality of, so what is the conditions here? X is greater than or equal to 0 and a is greater than or equal to 2. So the next condition would be x is less than 0, and a is greater than or equal to 2, x is greater than or equal to 0, and then a is less than 2, x is less than 0, and then a is also less than 2. So these are the possible conditions that you have. What are the corresponding equations? X square plus 2x plus a minus 2 is equal to 0, of course, is equal to 0. And then you have x square greater than 0, so minus 2x minus a plus 2 is equal to 0, and x square plus 2x minus a plus 2 is equal to 0. Here they are asking the values of x comma a. So let us do it for the first equation and then see what it brings up. So let me directly find out the value of x. How do you do that? You can use that minus b plus or minus formula, and then using that you get minus of minus 2 plus or minus square root of b square 4 minus 4ac, 4 into a into c, correct, divided by 2a, of course. So if I take out 4 from the square root, it becomes 2, and then I can cancel 2 on both the numerator and denominator. So what will I be left with? I will be left with x is equal to 1 plus or minus square root of 3 minus a. So this is your final value of x. So it is important to note that a is greater than 2, and then they're asking only integers. What is the value of a here? A is equal to 2 and 3, because it cannot exceed 3, as this function will become irrational, correct? Not irrational, it will become complex, it will become conjugate figure numbers. Therefore, what is the value of x for this corresponding values? So let me take a equal to 2. If I take a equal to 2, this function becomes 1. Therefore the values of x would become 2 comma 0 for a equal to 2. Next, for a equal to 3, what are the values? For a equal to 3, what are the values? It is just 1. For number of ordered pairs are how much? X comma a is equal to 2 comma 2, 0 comma 2 and 1 comma 3. So these are your 3 ordered pairs for the first equation alone. So first equation is done. Similarly, you guys can do it for the remaining 3 equations. I think you will get a total of 7. And the important thing to note here is, while doing this for other equations, the same ordered pairs might repeat. Correct? So once those repeat, obviously those need not be taken into account, and only the unique ordered pairs are what we'd have to focus on. So this basically brings us to an end for functions and graphs and modulus functions, right? So all these functions have a simple logic behind them. What is the different values of that function for different values of the input value ranges? With regards to modulus, that is true. With regards to our input values, that is true. And with regards to graph, it is important that you plot the graph and not do it blindly. Plot the graph, plot the functions, and plot the intersection points as well. So these intersection points are extremely important. Once you do that, you can easily identify where and how can calculate the areas for those functions. So let us meet in the next video. Thanks.